I'm sorry, I didn't see you there. I was too busy blocking out the haters.
You know what they say in Brooklyn? Haters gonna hate, and the players are gonna play my new game bonk. It has nothing to do with this video. Alright, so I posted this to Reddit, and some people got a little confused as to how it works. So I'm gonna go over some of the comments here, and then I'm gonna show off the latest version of it, and then I'm gonna and then at the end of this I'm gonna actually explain how it works, because I think some people don't fully understand yet. So sadly, faking reflections by sampling cube maps is not a new idea. He's correct technically that it's not a new idea, but this is not just sampling cube maps. Essentially, it's not just sampling cube maps, it's how it's sampled, right? That's what makes it completely different from anything that at least I've ever seen. Someone was mentioning that a Rockstar developer supposedly did something similar to this, but I couldn't find a video of it. Okay, so some skeptics were like, okay, so you need 6 extra forward passes and 6 extra depth passes per frame. Alright, so this, if you don't know what this means, it means that it should be slow. And the answer is, it's slower than screen space reflections, but it's also better than screen space reflections, because you actually get the reflection behind you. Which screen space sucks because it doesn't do that. And so the artifacts in screen space are so much more apparent than just the artifacts in this. And mine isn't even done yet, right? Like right now I'm only stochastically sampling GI, which essentially all that means is it looks really grainy. Hopefully in the final version it won't do that. And also it's not optimized at all, and that has barely anything to do with this, as much as it has to do with just the really slow way I'm sampling global illumination. So that's the biggest concern. Is the amount of times that I'm rendering cube maps, and it's like I'll just pull this over here, right? Okay, so you might see normal texture over here. At one point I was rendering a normal texture, but I'm no longer doing that. I'm actually rendering it at an incredibly low resolution. Alright, so I'm gonna show you the latest version of it, alright? At 1080p, alright? Let me alright, this is Unity graphics, alright? You see, the thing with Unity graphics is it looks terrible, right? And it's running at, right now, I'm not baking any probes, as you can see. Like, these 2 spheres over here actually visualize the baked reflection probe, and since these aren't updating at all, it shows that, like, I'm not re-baking the reflection probes right now. So this is how Unity is running right now. Of course, I'm running my recording software to actually record the screen. So let me turn on Mack graphics. Now, you see, the difference between the billion-dollar company's graphics and my graphics is very subtle. It's, you see, when you look at the lighting looks like the lighting that you would see in the real life, but it also looks better than Unity engine lighting, which is honestly exactly what I was going for. Now it's grainy. It's grainy right now. It hopefully won't be in the future. I have some ideas of getting rid of the grain. Hopefully not just denoising it the lazy NVIDIA way. Hopefully I have a certain idea in mind in particular that hopefully will work really well. If it doesn't, then I have to find something else. So since this is dynamic lighting, the things in it are dynamic, which means that I can pull this thing, like this metal sphere around, and it's not done yet, so like the reflections are kind of mid. Again, it's also not optimized yet, and yeah, it's slow because I'm running it with global illumination. That's like one of the slowest thingy-mabobs of all time on any rendering engine, but it's completely dynamic. I would consider this fast. All right, that's one thing that comments were saying on my video. It was like, this isn't fast, and I'm like, yeah, it is fast. It's just not as fast as screen space, and screen space is terrible, right? So the lighting is dynamic. It's the lighting does the lighting and the dynamic, and it's dynamic lighting. If I select this light right here, the light on the light is light, and it behaves like how light is supposed to be, right? At a distance, it's not working. In the final version, if my optimized, if my idea of how I can optimize the ray marching, which is it wouldn't even be ray marching at that point, it'd be a totally different thing, and I don't even think this idea has ever been done. Might be wrong. Once I implement that, the ray length will be infinite, but right now the ray length is finite, which means that if I move that far away enough, it probably won't show up in this. Yeah, it's that's not the reflection of it, that's the cutout, so that way it won't render it. Bring that over here. All right, so now I'm gonna show you that the graphics, it's best if this feature might not be in the final version, but there's an ability for infinite GI bounces. It's not the best, but it works. And you see, you can light the entire area with this one thing, and if I go behind it, it won't exist, right? If I like now the white isn't there, and it's only this, this is the capture of the actual cube maps. As you can see, it's at an incredibly low resolution, and you probably haven't even been able to notice, other than with the slight artifacting. Here's what the so I can even show you the lighting with no sunlight. So that's what this looks like. No sun lamp. Not really sure why you'd want to do this during like the day, unless it was like overcast, in which you'd want the like ambient occlusion, which, as you can see, this does ambient occlusion phenomenally, other than the noise. If it's at like sunset to the point where it's like so dim that there isn't a shadow at all, it looks kind of nice. And you can see that there's shadows, but it's not from a rasterized light. It's from my custom system. So again, it runs terribly right now. Actually, you know, I'm just gonna like real quickly, I'm gonna edit my code just to show you what it looks like when how fast it's running when I have just reflections on. All right. So they look kind of weird on any blurry or rough objects. But I mean, this is a significant improvement. It's still, my computer's very hot. So yes, it does take some performance trying to render cube maps, but you can render them at such a low resolution. These are both 128 by 128. I think I pulled this up earlier, but I hate Windows 11. I want Windows 7 back. Windows 7 is the best Windows. Alright, it's rendering at 128 by 128 on the position and the color texture. Okay, I have it back to normal now, and as you can see, the graphics are still graphics. But now it runs like 10 frames slower, and my computer's gonna catch on fire. Okay, so here's how this works, alright? I hate Windows 11. Why did they do this to my beloved Windows 7 Microsoft Paint? Alright, like, I like that it has transparent textures, but I don't like that this is how they implemented it. And I hate this too. I hate AI art. Screw you, AI. I'm gonna pour water on you. Alright, so it works like this. You see, you take, you draw a cube map, and this has like color, that says the scene color data, right? That's, yeah, and then you draw the other cube map, but this one, it does not have color data. This one has the position data. And so someone was wondering, how exactly am I capturing the data if I'm like doing it in like a float format? And no, it's not a float format. What I'm doing is I'm capturing it in the depth stencil format is a float format, but I don't really know what exactly that means. But the color format is not a float format, at least. I don't know what the depth stencil format is. I don't really care. Anyways, so the tracing part is actually really simple. You have the sphere probe, and then you have the and you have your scene variables like the world position and the normal position. You take the probe, and then you take the normal of whichever surface you're tracing, and then you just trace the reflection vector and march it by an iterator, and then it hits that, and then you can tell that. That's what I'm doing right now. My future idea is, you see, this requires a distance and samples, which means that it can't go for an infinite distance, and it requires samples, which means that anything that isn't hitting this point on these points on the iterator, it's gonna look not perfect. So anyways, thank you for watching my video. Like and subscribe to the video, and like the channel. Follow my Twitter, Xbox. Subscribe to my Instagram. Follow me on Snapchat. Hit me up on Yik Yak. Follow me on Vine. Like my Facebook, follow me on Reddit, subscribe to my Patreon, donate to my GoFundMe, allow notifications on my website. Shoot, I've been recording for 30 minutes. Oh, and on the topic of comments, I just got the actual dumbest comment I've ever seen. I was arguing that generative AI art is bad, and this guy goes ahead and hits me up with, "I do love to die on the altar of intellectual property to protect the class of independent artisans holding on to the last piece of aristocratic exceptionalism passed down to them from the 14th century. IP will be undermined, labor will be de-skilled, artistic production will be radically socialized such that there is no longer..."
Don't you lecture me with your $30 haircut!